137 meters long, 50,000 tons, designed to survive 30-meter waves, and it was built over 4,000 years ago. No power tools, no steel, no cranes. Just one man, his family, and a blueprint from God. For centuries, skeptics laughed at Noah's Ark, a children's fairy tale, a Sunday school cartoon. Impossible. But then Korean naval engineers decided to test the biblical dimensions. They ran the simulations, they crunched the numbers, they analyzed the structure. What they discovered silenced the critics forever. This is the engineering mystery of Noah's Ark. And today, we're finally solving it. Forget every Sunday school picture you've ever seen. Tiny wooden boat, giraffes poking out the top, happy rainbow in the background. That image isn't just wrong, it's an insult to one of history's greatest engineering achievements. Here's what the Bible actually describes. Genesis chapter 6 gives precise dimensions: 300 cubits long, 50 cubits wide, 30 cubits high. Using the royal Egyptian cubit, the standard measurement for ancient megaprojects, that translates to approximately 137 meters long, 23 meters wide, and 14 meters tall. Let those numbers sink in. 137 meters. That's longer than a Boeing 747. It's longer than a football field. The total volume? Over 40,000 cubic meters. Enough space to fit 450 semi-truck trailers inside. The displacement when fully loaded? Approximately 50,000 tons. This wasn't a boat. This was a floating warehouse the size of a modern cargo ship. Built in the Bronze Age, with hand tools. How is that even possible? The answer lies hidden in the original Hebrew text. 3 words that scholars have debated for centuries. 3 words that reveal construction secrets we're only now beginning to understand. But first, we need to address the most basic question skeptics always ask. If Noah somehow managed to build this thing, why didn't it just flip over and sink the moment it hit rough water? The answer involves a mathematical ratio so perfect, so precisely optimized, that modern engineers use virtually the same numbers today. A ratio that appears in Genesis chapter 6, written over 3,000 years ago. Here's what skeptics say. A wooden vessel 137 meters long would be catastrophically unstable in rough seas. It would roll. It would pitch. It would capsize the moment a serious wave hit it. And honestly, for most ship designs, they'd be right. But the Ark wasn't most ship designs. Look at the biblical ratio. 300 cubits by 50 cubits by 30 cubits. Simplified, that's a length-to-width ratio of 6:1. That number is not arbitrary. In shipbuilding, you're constantly fighting 3 competing forces. Make the ship too narrow, and it's fast but unstable. It'll flip in heavy seas. Make it too wide, and it's stable but rides rough. The violent rocking will injure everyone inside and stress the hull to breaking point. And if the proportions are wrong, the structure itself will twist apart. The 6:1 ratio is the sweet spot, the perfect balance between stability, comfort, and structural integrity. How do we know? Because modern supertankers and bulk carriers, vessels designed by engineers with supercomputers and centuries of accumulated knowledge, use virtually identical proportions. In 1604, a Dutch merchant named Peter Janssen built scale models to test different hull ratios. His conclusion? 6:1 was optimal for cargo vessels that needed to survive rough seas without capsizing. The shipbuilders of the 21st century arrived at the same answer as Genesis chapter 6. But here's where it gets remarkable. In 1993, Dr. Xian-Wan Hong and his team at the Korea Research Institute of Ships and Ocean Engineering decided to put Noah's Ark to the test. They built computer models. They ran wave tank simulations. They compared the biblical dimensions against 12 alternative hull designs. The results? The Ark's dimensions achieved the highest overall safety index of any design tested. It could withstand waves up to 30 meters. That's nearly 100 feet of solid water. It could tilt almost 90 degrees and still right itself. And here's the kicker. Any change to the biblical dimensions made the design worse. Picture it, a wall of water, 10 stories tall, roaring toward you. Modern cargo ships have broken apart in waves half that size. But the Ark, it rises up, it rides over, it settles back down. Not because of luck, because of mathematics. But perfect ratios don't float by themselves. You need materials. And here's where we encounter the most mysterious term in the entire construction account. Genesis 6:14. Make yourself an ark of gopher wood. Simple enough, except for one problem. The word gopher appears nowhere else in the entire Bible, not once. Scholars call this a hapax legomenon, a one-time word with no parallel to help us understand its meaning. For 3,000 years, translators have guessed. But recent research suggests they've been asking the wrong question entirely. There are three major theories. Theory 1. Cypress wood. The Hebrew gopher sounds similar to kupar, an ancient word for cypress. And cypress makes sense. It's naturally rot-resistant, filled with protective oils, and it's the wood Phoenician shipbuilders prized above all others. Alexander the Great built his fleet from cypress. Theory 2. It's not a type of tree at all. The Septuagint, the ancient Greek translation from the 3rd century BC, renders it as squared wood. The Latin Vulgate says smoothed timber. Under this interpretation, gopher describes a process, not a species. Squared beams, planed surfaces, precision-cut lumber designed for tight-fitting joints. Theory 3. The most intriguing possibility. What if gopher refers to laminated wood? Multiple thin layers bonded together, essentially ancient plywood. This would eliminate natural weaknesses like knots and irregular grain, creating beams stronger and more uniform than any solid timber could provide. What if the Bible isn't naming a tree, but describing a technology? Now add the second instruction from Genesis 6:14. Cover it inside and outside with pitch. This is crucial. The Hebrew word here is gopher, bitumen, natural tar. We know from archaeology that bitumen was abundant in the ancient Near East. Genesis 14 mentions tar pits in the region. The material was readily available. But notice, inside and outside. The wood wasn't just waterproofed, it was sandwiched in tar. This creates something remarkable, a composite material. Wood provides structure. Tar provides waterproofing and protection against shipworms, those wood-eating parasites that have destroyed countless vessels throughout history. This wasn't just a wooden boat with some caulking. This was a sealed survival pod, a 137-meter cocoon wrapped in waterproof armor. But skeptics still had one card left to play. They pointed to a ship called the Wyoming, the longest wooden schooner ever built. And despite all our modern knowledge, it leaked. Constantly. And eventually, it sank. The USS Wyoming, launched in 1909, the longest wooden schooner in modern history, at about 100 meters. It was a disaster. The problem? Something called hogging and sagging. When a ship crests a wave, the middle is supported, but the ends hang free. The hull bends upward. When it straddles two waves, the opposite happens. The middle droops. Back and forth. Constant flexing. Joints loosen. Seams open. Water pours in. The Wyoming required constant pumping to stay afloat. In 1924, it sank with all hands. So here's the skeptic's challenge. If a 100-meter wooden ship couldn't stay watertight in the 20th century with all our modern knowledge, how could a 137-meter wooden ship survive in the Bronze Age? The answer lies in what the Ark was not. The Wyoming was a schooner, built for speed, with a sleek V-shaped hull and 6 massive masts. Those masts acted like lever arms. Every gust of wind translated into twisting force on the hull. The elegant shape that made it fast also made it vulnerable. The Ark was nothing like that. No masts, no sails. It didn't need to go anywhere, just float and survive. The hull was essentially a box, a giant rectangular barge. And that boxy shape, which looks primitive, is actually structurally superior. A rectangular cross-section has a much higher moment of inertia than a V-shape. In plain terms, it resists bending far more effectively. Add 3 internal decks running the full length, like floors in a building, and you've created what engineers call a box girder. The same structural principle used in modern bridges. But the real secret lies in how the planks were joined. Modern wooden ships in the 18th and 19th centuries used frame-first construction. build a skeleton, then nail planks to it. The problem? Nails loosen, holes enlarge, joints fail. Ancient Mediterranean shipbuilders used something far more sophisticated: mortise and tenon joinery. They carved slots into the edges of each plank, inserted wooden tongues to connect plank to plank, then drove wooden pegs through the joint to lock everything together. The result? Planks joined edge to edge across the entire hull. A shell construction where the skin itself bears the load. And here's the beautiful part. Wood swells when wet. The wetter those joints got, the tighter they became. The sea's assault actually strengthened the structure. Hear the rhythm. Mallet on chisel, chisel on wood. Thousands of joints, tens of thousands of pegs, each one carved by hand, each one driven into place, day after day, year after year, building something that would outlast a global catastrophe. The hull was sealed. The structure was sound. But one question still remained, the hardest question of all. How do you keep thousands of animals alive inside a sealed wooden box for over a year? Let's count the challenges. Conservative estimates suggest around 16,000 animals on board, counting by biblical kinds, not modern species, plus 8 humans. Duration, 371 days, over 1 full year. No electricity, no mechanical ventilation, no running water, no waste disposal system. The problems are obvious: oxygen depletion, carbon dioxide buildup, ammonia from waste, which becomes toxic at high concentrations, heat buildup from thousands of animal bodies, disease from unsanitary conditions. By every modern calculation, everything inside should have suffocated within weeks. Unless the Ark had systems we've overlooked. Genesis 6:16 contains a curious instruction. Make a tsohar for the Ark, and finish it to a cubit from above. Most translations render tsohar as window, but Hebrew already has a word for window. It's chalon. Tsohar is different. Its root meaning relates to noon, or brightness, or shining. What if this wasn't a small window at all? Many naval architects now believe that tsohar was a continuous opening running the entire 137-meter length of the ship, just below the roofline, about half a meter high, protected by overhanging eaves to deflect rain. Not a window, a ventilation system. Here's how it works. Thousands of animal bodies generate heat. Decomposing waste generates more. Hot air rises. It flows upward through the ship and exits through the tsohar gap. This creates negative pressure below, which pulls fresh air in through lower openings. It's called the stack effect, passive ventilation requiring no moving parts. The ship breathes automatically, powered by nothing but basic physics. But some researchers propose something even more ingenious: a moon pool. Imagine a shaft in the center of the ship, open to the sea below. Modern offshore platforms use these. As waves rock the vessel, water in the shaft rises and falls like a piston. That piston action pumps air through connected channels, forcing ventilation into the lower decks where it's needed most. The same system provides wave dampening, a smoother ride for the animals. And it offers a direct route for waste disposal. Shovel it into channels leading to the moon pool. Let the sea carry it away. Breathe in. Smell the hay, the animals. Now feel it. A cool breeze rising from below your feet. The moon pool surges with each wave, pushing fresh air through channels in the floor. The whole ship is breathing.